Chapter 24 Euclidean and Non-Euclidean Continuum. The surface of a marble table is spread out in front of me. I can get from any one point on this table to any other point by passing continuously from one point to a neighboring one and repeating this process a large number of times, or, in other words, by going from point to point without executing jumps. I am sure the reader will appreciate with sufficient clearness what I mean here by neighboring and by jumps, if he is not too pedantic. We express this property of the surface by describing the latter as a continuum. Let us now imagine that a large number of little rods of equal length have been made, their lengths being small compared with the dimensions of the marble slab. When I say they are of equal length, I mean that one can be laid on any other without the ends overlapping. We next lay 4 of these little rods on the marble slab so that they constitute a quadrilateral figure, a square, the diagonals of which are equally long. To ensure the equality of the diagonals, we make use of a little testing rod. To this square, we add similar ones, each of which has one rod in common with the first. We proceed in like manner with each of these squares until finally the whole marble slab is laid out with squares. The arrangement is such that each side of a square belongs to 2 squares and each corner to 4 squares. It is a veritable wonder that we can carry out this business without getting into the greatest difficulties. We only need to think of the following. If at any moment 3 squares meet at a corner, then 2 sides of the 4th square are already laid, and as a consequence, the arrangement of the remaining 2 sides of the square is already completely determined. But I am now no longer able to adjust the quadrilateral so that its diagonals may be equal. If they are equal of their own accord, then this is an especial favor of the marble slab and of the little rods, about which I can only be thankfully surprised. We must experience many such surprises if the construction is to be successful. If everything has really gone smoothly, then I say that the points of the marble slab constitute an Euclidean continuum with respect to the little rod, which has been used as a distance, line interval. By choosing one corner of a square as origin, I can characterize every other corner of a square with reference to this origin by means of 2 numbers. I only need state how many rods I must pass over when, starting from the origin, I proceed towards the right and then upwards in order to arrive at the corner of the square under consideration. These 2 numbers are then the Cartesian coordinates of this corner, with reference to the Cartesian coordinate system, which is determined by the arrangement of little rods. By making use of the following modification of this abstract experiment, we recognize that there must also be cases in which the experiment would be unsuccessful. We shall suppose that the rods expand by an amount proportional to the increase of temperature. We heat the central part of the marble slab, but not the periphery, in which case two of our little rods can still be brought into coincidence at every position on the table. But our construction of squares must necessarily come into disorder during the heating, because the little rods on the central region of the table expand, whereas those on the outer part do not. With reference to our little rods, defined as unit lengths, the marble slab is no longer a Euclidean continuum, and we are also no longer in the position of defining Cartesian coordinates directly with their aid, since the above construction can no longer be carried out. But since there are other things which are not influenced in a similar manner to the little rods, or perhaps not at all, by the temperature of the table, it is possible quite naturally to maintain the point of view that the marble slab is a Euclidean continuum. This can be done in a satisfactory manner by making a more subtle stipulation about the measurements or the comparison of the lengths. But if rods are every kind of material were to behave in the same way as regards the influence of temperature when they are on the variably heated marble slab, and if we had no other means of detecting the effect of temperature than the geometrical behavior of our rods, in experiments analogous to this one described above, then our best plan would be to assign the distance 1 to 2 points on the slab, provided that the ends of one of our rods could be made to coincide with these 2 points. For how else should we define the distance without our proceeding being in the highest measure grossly arbitrary? The method of Cartesian coordinates must then be discarded and replaced by another, which does not assume the validity of Euclidean geometry for rigid bodies. The reader will notice that the situation depicted here corresponds to the one brought about by the general postulate of relativity in section 23.